I'm gonna, I don't know about you guys. I think I'm working. Sorry.
What does array mean again?
Like,
A-R-R-A-Y.
oh, an array. An array is kind of like a matrix on the computer screen, like the pixels on the screen,
Got it. That's
but
all.
it'll be like the capture. What's on there? It's an array, a set of detectors.
Okay.
Yeah. All right, good. So you've got your notes in front of you. Follow along using the notes. These are just mirroring the PowerPoint notes that I'm using. Take notes on things that I say that are different from what's written, what's printed for you. Let's go ahead and jump into this. So let's just define, get out of the way our terminology here, right? So I showed you two types of digital image receptors. One was called CR, the other called DR. They're both digital, and that's an important thing to remember, right? CR just stands for computed radiography. The image receptor has no direct connection to the image processor. As you saw, I pulled a white plate out of there, right? That plate's not directly connected to anything. You have to take that plate and put it into a processor. Each time you take an image, the plate gets brought to a processor, that little white plate gets pulled out, processed, and then stuffed right back into the cassette to be reused again. There's no direct connection to the processing device. This was first called filmless radiography. And you can see that it's very similar, right? There's a thing like film, but it's a plate now, right? And it's taken out of the cassette each time we take an image. Okay? It's just reusable. That's the main big difference. DR, standing for direct capture radiography or direct capture digital. DR does not stand for digital radiography because both of these CR and DR are forms of digital. The image is displayed on a computer screen.
Okay, so they're both digital.
Mhm.
DR doesn't stand.
DR stands for direct radiography. It's got a longer term that they give here, but it just means direct radiography. So the D stands for direct. Important thing about DR is that it doesn't require the image receptor to be carried to a processor that is separate from the exposure unit, meaning that you take an image of your patient, you don't have to go get the image receptor. The image just shows up for you on your computer screen without you doing anything because there's a direct connection between the plate and the computer, okay? Now, in the case of ours, it's got, in the back here is a place for a battery, right? It's battery powered unlike the other two. I turn this on, and it connects by Wi-Fi to my computer. Okay, some of you have been in my lab and have done the experiments, right? You leave the image receptor in the room, in the X-ray room, with the closed door. You make your exposures, and then you just turn around and look at the computer screen, and oh my gosh, your image is up on the computer screen in seconds, right? So there is a direct connection, wireless or wired, but a direct connection between this plate and the computer screen in very much almost an identical way that when I turn my camera on, right, and we take a picture like that, yeah, there's a direct connection between the camera detector and my screen on my phone. Right now I go click on that.
So it goes straight to the gallery.
Straight
That's
to
the
the gallery,
same concept.
right? That's the same concept,
And
right?
there's no capacity, like max capacity?
The computer has the storage.
Oh, like the gigabytes?
Right, the computer has a hard drive, right? Just like on my phone, there's a drive, not a hard drive, but a storage drive, right? And this picture is now stored on my phone, right? In very much the same way, when I make an X-ray exposure on this, that image goes directly to the computer's storage, right? And we can view, display, and just like I can go and take this image on my phone, and I can let's go back to it. There you all are, bright and shiny people. I can go ahead and take it, I can edit this, I can crop it, I can put filters on it, I can flip it around, I can do all kinds of stuff to it, right? I can do all kinds of stuff to the image that I produced on this because it's stored digitally, and we can change that information, okay? Okay, so direct connection to the computer, it is very much the same as a digital camera, okay? It's just the sensitivity of the detector is different, right? A digital camera is sensitive to visible light, right? This is sensitive to X-ray light, okay? okay? And I can't emphasize that enough. You'll learn this in physics. X-rays are just, they're not a mysterious thing. They're just a different kind of light, okay? They're a kind of light that you cannot see, okay? You don't have any sensory perception for it. You can't see it, can't feel it, can't taste it, can't hear it, okay? And they pass through your body without you knowing it, okay? And because they pass through your body, we can take images of the shadows of the inside of the body, right? Pictures of bones, in other words. All right, so direct connection between the computer and the imaging plate. Okay. This was first called cassetteless radiography because the first versions of this didn't actually have a cassette. The first versions of DR were built, the detectors were built into the tables, and they were built into the walls, okay? Nothing was movable. This is nice because I can just buy this, and I can stick it right in my table, right? I don't have to go get a whole brand new x-ray room, okay? DR used to be very, very cost prohibitive because the detectors were built into the table. So if you were an office that was using film, and you wanted to get the newest DR stuff when it first came out, you had to buy a brand new table. You had to buy a brand new wall holder, okay? And these, of course, tens and dozens of thousands of dollars, right? You had to buy all this brand new stuff. Now I can just go and buy this plate, buy the computer that runs the plate, okay? And I'm up and running. I don't have to change anything in my x-ray room. If you've been in my x-ray room, you've noticed that it's got a lot of old stuff, right? The x-ray machine's pretty old, right? My table's pretty old. My control console's pretty old, but my detector's all brand new because I was able to just buy this and stuff it right in and have it work. Right? This is separate now. They used to be built directly into the table, which is where we got the name cassetteless radiography from.
Will you know which one's which? Like automatically?
How do you mean? I'm not sure what you're asking.
Like, are you gonna be able to tell?
Oh, like when you go into an x-ray room, you'll be able, yes, you should be able to tell after going through the lecture here.
Oh,
You should be able to tell the difference when you go into a room, right? For one, if your receptor is battery powered, it has to be DR. Okay, so if this image plate, right, if it runs on battery, right, if it's got a place to put a battery in it, it's a DR system, 100% of the time.
that's what I'm trying to ask. Like,
Yes.
How do you tell?
Yes,
apart?
and if you go into an x-ray room and you have to take this plate to a processor every time you take an x-ray, and it's reusable, then it's CR, 100% of the time. If you go into an x-ray room and you have to put in and take out a piece of film every time you take an x-ray, then it is film every time.
So places still have that?
Some do, yeah. This is being absolutely phased out because there's a requirement nowadays for images, whether taken analog or digital, to be digitized. So everything has to be stored on a computer now for EMR. So anywhere that uses film has to have a way to digitize their stuff. If they didn't have a way to digitize it, they would have to go buy all that stuff. So they might as well just go ahead and buy the digital stuff and switch over, right? So everyone has. I don't have any clinical sites any longer for you guys that are film. Up until a couple of years ago, I had clinical sites that used film. None of us do anymore. Yeah. So yeah, what's nice is that I get all this stuff and all these offices switch to digital, so they give me the old stuff for me to show you. So you probably won't ever see film again. Okay.
So we would mostly just see those two.
Yeah, you're just probably not going to see film X-rays ever being used again. Digital is the standard now. One bummer thing though, and we'll talk about this when we get back around to principles of exposure, which is the module we just finished. If you're brand new, you didn't do it. But you can't get better than the resolution, than the spatial resolution of film. The spatial resolution, the detail that film can give you, is unmatchable with current technology. Okay, so the images were in some ways much better with film than they are with digital, but the added advancements of digital, the image editing and all that, the contrast resolution is much improved. So to the human eye, it looks better digital, but you can't beat spatial resolution of film. But anyways, yes. Long story short, you should be able to tell the difference when you go into a room. And if you don't know, if you're not sure, just ask. It should be pretty straightforward, though. This shows you an example of a cassetteless DR system. The image receptor detector is built directly into that little tabletop thing. Okay, so let me zoom out and point at it. So this thing here, the image receptor detector is built directly into that. You have to bring the patient to that, right? With my digital, with the new DR stuff that are in plate form like this, I can take that plate and put it, anywhere in the X-ray room, okay? But with the first kinds of DR that came out, again, these things were fixed in place. And if you wanted to take an X-ray, the patient had to get put in position on this plate. You couldn't move anything really around. Okay, and it's nice nowadays to be able to take that plate and move it to the tabletop, move it to the wall, move it around if I need to. Okay, so for DR, the table or chessboard would house a permanent array of miniature radiation detectors. That's still true, by the way. The DR plates that we have still house an array of detectors in the same way your phone's camera houses an array of detectors, okay? It's just a matrix, a square of individual little detector cells that detect X-rays. They're tiny, they're nearly microscopic, the size of these detectors, so we can't see them like you would be able to see pixels on a computer screen. But they're there, miniature radiation detectors. DR projections, by the way, projection is another way to say like making an exposure, taking an X-ray. So DR X-rays must be done as single field images, I'll explain in a moment, centered to one of the AEC detector cells, further limiting position. Let's unpack that. So an X-ray taken on a direct capture system, one that's directly connected to the computer, as soon as you make the exposure, the image is sent to the computer. Okay? You cannot, like we used to be able to do with CR and film, you cannot take multiple images of a body part on one piece of film, in other words. Okay? Every image is separate from the one before that. Okay? With film, and I don't have any good examples of this, but with film, you could take, so you want to take a picture of like a hand, right? You take a front view, an angle view, and a side view. Okay, and you can do all three of those on one piece of film. You can even, I gotta be nice to this thing. You can even do that with CR. Both of these, there's no direct connection to the computer, right? There's no battery pack, no Wi-Fi connection, right? So both of these, you can take multiple images on here, right? Multiple different images in different positions, just in different spots on the piece of film.
Like a collage?
Kind of, yeah. Yeah, if you want to think about it, I think that's an okay way to think about it. And display all of them at one time. Okay, on the screen or on the view box at one time. Okay. Now, why would you do that? It started with film because let's say I want to take a picture of a hand, an X-ray of a hand, right? I put the hand on the film. Let's say I want to center it up. By the way, these come in different sizes. Okay, this is the biggest size, 14 by 17 inch. But we would choose different sizes based on the body part. But let's say I had a big one like this, and I was going to take a picture of a small body part, like a hand. Okay? Take the radiograph of the hand's in the center, you process the film, we've got one radiograph of the hand, but there's all this like wasted space, okay? And this thing costs money, right? Every time I take and use a piece of film, I'm using $1 or so of the office's money to do that. Okay, now that of course the patient's putting the bill for it, but the more you use, the more supplies that you use, right? The more money this operating this system costs. Okay, so it was advantageous with film to take and make multiple exposures on a single piece of film. That idea about saving money got turned into just a practice that X-ray techs did. Okay, X-ray techs, when they could, made multiple exposures on a single piece of film. Then when CR came out, we did the same thing. Okay, it wasn't to save money anymore. It was just because this is how we all had been taught. Okay, and so with CR, we would make multiple exposures on one piece of one image plate, and then we go take it to the processor after those exposures were done. The added advantage here is that each time you take the thing to the processor takes about a minute or two to process the image. So if I took this 3 separate times to the processor, I'm now taking 3 to 6 minutes of processing time. If I only have to take it to the processor once, I'm using a minute or two of processing time. So I'm saving time. Right? It was saving money and saving time, which is why we did multiple projections, multiple images on a single plate or single piece of film. However, with DR, because of its direct connection to the computer, as soon as I put my hand on here and as soon as I make that X-ray exposure, that image is sent directly to the computer. There's no time for me to put the patient in one position, take the image, another position, take an image, and another position to take another image, right? There's just no time for that. The image is sent directly to the computer with each exposure. So X-rays done on DR must be taken as a single field, one body part at a time, right? One position at a time. And DR needed to be centered to something called an AEC detector cell. AEC, if you haven't heard that term before, stands for Automated Exposure Control. Let me go back to the picture. In this picture on this plate, you notice, kind of zoom in on it, right in sort of the middle of the plate, there's a single dark rectangle and two circles, like looks like a little face, like eyes and a nose, right? Those are AEC detector cells. Those little chambers that are underneath that plastic cover, those little chambers can detect when the right amount of exposure has been reached and shut off the exposure, okay? Which is nice because if you've been in the X-ray room with me, some of you have, some of you haven't, but if you have been in the room with me, you know that before we take an image here at the school, we have to set something called technical factors, right? We have to tell the X-ray machine how much radiation to use to make it X-ray, to make an image of the body part we're looking at, right? And it's different for every body part. It's one of the things that people worry about the most is setting your technical factors for the image you're gonna take, okay? Kind of like on your phone when you take a picture, you have to make sure the exposure lasts for, like a literal picture on your phone, you have to make sure the picture exposure lasts for a certain amount of time so that it's not overexposed or underexposed, too wide or too dark, okay? I know you don't set your exposure times on your phones anymore, but you can on some, and your phone's doing it for you, right? But you have to set the right exposure time. You have to make sure the exposure lasts for the right amount of time on a picture. In X-ray, because X-rays, you make your own light. You're not using the light outside of in the world, right, like cameras do. You make your own light. You have to decide how much light to make, right? How much X-rays to make, how much radiation to create, and how long to make the exposure last for. With AEC, it does it for you. You just press expose. And the machine, the software and hardware work together to decide when the exposure should stop, when the right amount of exposure has been reached. This only works if the body part is placed on top of those detector cells, okay? If the body part is placed anywhere else but on top of those detector cells, this of course won't work. Okay, you need the body part in the way of those detector cells. So you're sort of very because it always has to be done single field, and because you had to use those detector cells, you were sort of very limited to your positioning flexibility, how much wiggle room you had to position your patients. This is becoming less true nowadays. They say the fixed nature, the fixed nature of this system limited positioning flexibility somewhat compared to CR. This is becoming less true nowadays because, as you just saw, those three plates that I showed you are all very similar. They can all be moved around. Okay, so this is changing, but still is somewhat true. Mobile radiography. I don't know if you've heard about mobile radiography. It's not something that a limited X-ray tech can do, which is why your program is called Limited X-ray Technician, right? But radiologic technologists can do mobile radiography. Mobile is just having a unit that can roll around and is battery powered, okay? The mobile units, the receptor plate is what used to be, it's getting better now, but used to be very bulky and attached by a cord to the machine, making it harder to maneuver around the patient. As they say, more modern units use radio waves, Wi-Fi. You know Wi-Fi uses radio waves, right? Uses Wi-Fi to be cordless, wireless. Nowadays, DR is as cheap or cheaper than buying CR. CR was first. DR came on the scene later. CR had the advantage that it was always better at spatial resolution detail, okay? But advantages nowadays is that DR, direct radiography, direct connection to the computer, this is getting a lot cheaper and more cost effective. Even before that though, there were two main advantages. So even when it was very, very expensive, there were two main advantages here. High compatibility with the Picture Archival and Communication System, or PACS. We'll talk about PACS later today. So very compatible, because it just goes directly to the computer. It's just no thinking about it. So it goes directly to the computer, it's the right kind of file, everything's happy and easy, okay? And then increased departmental efficiency for workflow, basically meaning that things happen quickly for you, right? With CR, computed radiography, the plate, you put the plate under the patient or behind the patient, take the exposure, take the x-ray, tell the patient to relax, you go get the plate, you take it out of the x-ray room to your processor, okay, which might be on the other side of the hospital, okay, and you go process it, takes a minute or two to process it, comes up on the screen, you go, oh man, I gotta do this again, I gotta repeat something, my positioning was bad, or I accidentally clipped off some piece of anatomy. So you grab a new plate, you run back to the patient, they've moved by now because you've been gone for a couple minutes. So now you completely reposition them, okay? Hoping to remember how you positioned them last time, right? And fix it a little bit. And then you make a new exposure. And then you go back to the processor and it takes a couple minutes to process again, okay? This was, by the way, even worse with film, okay? Because you had to go into the dark room. That made workflow just kind of slow. You know, with CR, I would take, let's say I had an exam that had 10 images, 10 positions, okay? It was not infrequently. You would get a big exam sometimes. You got an exam that has 10 positions, right? So hopefully my office has this, not all do, but I'm gonna take 10 imaging plates with me, okay? And I'm gonna go to the x-ray room, and I'm gonna put one in, make the exposure, pull it out, put it off to the side behind the wall. I'm gonna put the next one in, next position, next exposure, and I'm gonna do all of these. And then I'm gonna take them all to the processor, and I'm gonna go up and process all of them, okay? This of course depends on how close your processor is to you. If your processor is very close, or if you only have a couple of plates, you can be even more limited. So, but anyways, I had to do all my positions, take all my x-rays, and then go process them. That's how film and CR work. You basically took all of your x-rays, took all of your images, and then you went and processed it, okay? And by the time you get done, you may have to repeat a couple of them because of exposure issues, because of positioning issues, okay? With DR, I take the image, plate stays behind the patient, right? I take the image, plate stays behind the patient. I can just ask the patient to keep still. In like 2 seconds, my image is on the screen, and I can tell very quickly if I need to repeat anything, okay? If I have a repeatable error. And then I'm right back to the room within seconds to fix that error, okay? And importantly, I don't have to move this, okay? Some exams are done tabletop, where the cassette literally sits on the table and the patient is laying on it, right? If it's CR or film, I've got to go get it out from under the patient, okay? They can be in lots of pain potentially, okay? It's hard to move things. If it's, it's hard, you want to move things as little as possible, right? With DR, I don't have to move it, okay? And if I made a positioning error, I know it very quickly, and I can fix that error without having the patient have chances to move very much, okay? So it was easier to fix errors. We've increased our efficiency for workflow. We'll talk about detective quantum efficiency later, but DR has a higher detective quantum efficiency. Okay, so what we're gonna do now, and for the next little section